This is a video of the most common errors that were made with the Intro to Engineering Design Unit 5 assessments. Um, one that came up a bunch of times was when you need to find the area of an ellipse. It looks like a lot of students um, mistook the major and minor axis as A and B. So the area for the ellipse is actually pi AB, and the A and B are half of the major and minor axis. And usually in these problems, you're given the major and minor axis. And so if you just plug those straight in, you're not going to get the correct answer. And so you just need to make sure that you're using half of them. So in this case, the area would be pi times A, which is half of the major axis, or 5 centimeters, and B, which is half of the minor axis, or 2 centimeters. And then when you plug that into the old calculator, it would be pi times 5 times 2. And if you have this type of calculator and it shows up like this, you can just hit this little button down here, and that changes it into a regular old number. So 31.41, and because, sorry, 31.4, and because it is area, the units are going to be squared. So this one will be centimeters squared. All right, then another common problem that came up a bunch of times was just the area of a triangle. It would appear that sometimes we're given like an obtuse triangle maybe, and the question maker will try to trick you by giving you like one of these side lengths. Just make sure that you're always using the height. And I think that that's a common problem, is that whatever the triangle looks like, figure out what the base is. So in this case here, let's say the base was 2 centimeters, and whatever this height is, make sure that you use the height in the formula. So the formula for the area of a triangle is going to be 1/2 base times height. So I just like to write that as base times height over 2. And so let's go with this one here. Let's say that this height was 3. Your area is just going to be 2 centimeters times 3 centimeters divided by 2. And this one's kind of cool because the 2's cancel, and you would be left with 3 centimeters squared. All right, for this one right here, your area would be the base, which is 3 times the height. So ignore these distractors. The height would be 3 as well, divided by 2, because it's a triangle. And so that would be 9, and we should have inches in there as well, 9 inches squared over 2, which would be 4.5 inches squared. All right, so this one isn't too difficult. I think sometimes you just need to slow down a little bit and make sure that you're actually grabbing the height and not one of the side lengths. All right, next common error for circles. I think circles is just a case of slow down and look at the equation, and most of the errors are just mixing up the diameter and radius. So just slow down, look at the information you have, and make sure that you're using the diameter when you should be using diameter and radius when you're using radius. And also just being really careful that you're actually using the area or circumference formulas correctly and that you're not mixing those up. So if that means pulling out your formula sheet or even Googling just to refresh your memory, make sure that you know them. I don't think there's anything too complicated about applying these, but just make sure that you slow down and make sure that whatever number you're given, that you know that it's radius or diameter and that you apply it correctly. I think that's all you need to know about circles and finding the area or circumference. All right. This next problem that seemed to cause a bit of grief is a surface area of a cube. And I think this is another one of look up the formula, slow down, make sure that you're applying it correctly. So A cube by definition has all of its side lengths are equal, so it'll be your base, height, and depth will all be S, which in this case is 5 inches. And if you're looking for volume, it'll be S cubed, which in this case will be 5 inches cubed. And an important piece of both the area and surface area is the units. And so 5 cubed is what, 125? 125, and just make sure your inches cubed are your units. So for volume, your units always have to be something cubed. Then for surface area, your formula here is 6 times the side length squared. And so it's just the surface area. It's the area of how much wrapping paper you need to wrap this, or paint to paint it, or whatever it is, just to cover the exterior. And so 6 times, in this case, 5 inches squared is going to be 30 inches squared. All right, so your units have to be something, a unit of length squared for surface area and a unit of length cubed for volume. All right, next common issue. So this one here is more of a definition thing. There were a lot of wrong answers in terms of mass and weight. So for your mass is just how much stuff there is, how much matter. And examples of mass would be kilograms. And in the SI unit, sorry, in the US customary units, slugs is what we could use for mass, although it's not used too very commonly. And then weight is actually a type of force. It's how much mass is being pushed down by gravity. All right, and so this is the one that people will talk about. Hey, how much do you weigh in outer space, or on a planet, or on the Earth? And so depending on what the local gravity is, that could change. And so weight is dependent on gravity, and it's an actual force. And so newtons or pounds are your common units that we'll use for weight. Then these are two formula that that combine the concepts of mass and volume with density. So density is how tightly packed stuff is, how much mass or matter there is per unit volume. And this is the formula that unifies that information. And so this comes up a few times, and what will happen is you'll be given maybe the mass and the mass density, and you'll need to find the volume. And so being able to rearrange either of these, and so these are similar formula, but one is for mass and one is for weight. Being able to rearrange these is fairly important. So let's just look at the weight equation. So in abbreviations, that would be written as W equals V, and then D with a subscript W for weight density. So I've just rewritten this. Weight is volume equals volume times weight density. That's what this looks like. So what if you were to be given a problem where you were given the weight and you were given the weight density and you needed to solve for the volume? Being able to rearrange an equation like this is an important thing to be able to do, but sometimes you need a quick refresher on this. And so what we're going to do is, to get volume all by itself, we're going to just divide both sides by the weight density. Right? So whatever you do one side, you have to do the other. These cancel out on this side because they're on the top and bottom of the fraction. And so then V is by itself. So if we were to be solving for V, we would now have volume equals weight over weight density. All right, so that's how you would rearrange that equation if you had to solve for the volume. All right, next common error. So this one here is similar to what I talked about just a moment ago with the radius of a circle, the equations for a circle. But what if you now had the formula for the circle area equals pi r squared, and you had to solve for the radius, all right? So let's just rearrange this equation so that r is all by itself. So let me just quickly step you through that and just remind you how we can rearrange an equation that looks a bit like this. So to get r by itself, first of all, let's get rid of pi. Well, let's first start by just dividing both sides by pi. The top and bottom cancel here, so we're left with r squared equals area over pi. And so then to get rid of this squared, we are going to take the square root of both sides. So the square root of that, square root of that. So taking the square root of something that's squared ixnays the square root and the squared. So they kind of drop off on this side, and you're left just with r, which is exactly what we had wanted. And then this side is going to be the square root of area over pi. So if we rewrote that, it would be radius equals square root of area over pi. And that's how you can rearrange this equation if you had to solve for r. And that is all that I'm going to go over right now. I hope that helped.